Hi, and welcome to this section of the TI-89 Calculator Tutor. And in this section, we're going to learn how to use the graphing abilities of this calculator to find the slope of a curve at a given point, and also the equation of a line tangent to the curve, which we'll find out that these two things are really related intimately. So what we need to do is let's choose a clean function here that we all know how to work with, x squared, let's say minus 1. And we'll find out why this is useful here in a second. The main reason is it's just a nice sweeping parabola. It's easy to visualize, but everything we're about to talk about is directly applicable to any function that you could plot here. So let's talk about two things. What does it mean when we say the slope of a curve, really? What it means is if if I had a straight line here instead, right? If I had a straight line, everybody here could calculate the slope of that line, rise over run, right? How far up does the line go compared to how far over does it go? We divide the rise divided by the run, and that's going to give us a number that's going to basically indicate how steep that line is. It's what we call the slope of that line. So it's kind of easy to visualize for a line, but when you have a curve like this, something that's constantly changing, bending over, so to speak, if I wanted to look at this point right here, what would be the slope of the curve right here? Well, obviously it's fairly steep right here because the function is getting steeper compared to, let's say, down here. Down here, the line or the curve is kind of bending over, so it's not nearly as steep here. Now, mathematically, the way you define it is when you look at this, you say, well, okay, at this point, if I were to draw a line tangent to this curve, just tangent to this curve, tangent means it just barely touches this curve in one spot, only one spot right here. Let's say we're looking right here. If I could draw a line that just barely skirted the surface, if I could find the slope of this line that just barely touched it, then I would know this, what we call the slope of this curve at this point. The slope of the curve at a point is basically equal to the slope of the line that just barely touches that curve at that point. We call it the tangent line. So if you look down here, and I've found a tangent line down here somewhere, that line would just barely touch, let's say, just like this. Well, the slope of this line down here is much less than the slope of the line that would be crossing up here. So the slope of this curve, bottom line, is changing all the time. No matter where you look, whatever point you investigate, the slope of this curve is steeper up here because the curve is going north, so to speak, much faster, so it's a higher slope. And down here near the